see other comparisons here too. And this is our overall somehow judgments of what types of artificial intelligence methods being used in each of these imageries. So we can see for multispectral, it is widely machine learning that it is used, while for RGB we have deep learning. And another category, for DL-based ones, we actually go for classification, segmentation, and detection, while for machine learning-based models, we are mostly dividing our work into supervised and unsupervised methods. And these are the challenges for state-of-the-art works that we are still facing. First one is the lack of enough data sets. So we can't actually train our models efficiently. There is a strategy being decided to actually be used in this case, which is using generative AI for actually producing more images and somehow enhance our dataset. And these are the other disadvantages that we are facing, and actually the impact it makes on our evaluation. But as you see, there are solutions for it. So at the end, we want to focus on one specific and important article, which is PDT, UAV Target Detection Dataset for Pests and Diseases 3. So here, this article has mentioned that it is using two models of two actually different types of datasets. One of them is called PDT dataset, while the other one is CWC dataset. And this one is low resolution, while the other one is high resolution. So they're using DJI camera, which has taken its data from 150 meters height, which is pretty high. So the dataset one of these datasets can be considered as high altitude. So as you see, this is one sample of their image, but this image can't be processed by the model. It should be first cropped into smaller images, so that we can fit it to our model here actually, and it will actually do the processing and then training for us. And this is the PDT dataset, which is just somehow multiple images of our tree. But here we have CWC datasets, which consists of multiple vegetables from a low altitude images being taken. This is the overall structure of the YOLO DP baseline model architecture, which this paper has used and developed. We have FPN and PAN module being used that consists of GhostCom, which is here, which is the initial steps of our data being fed into the model. And then we have upsampling, which can be considered as a decoder, and at the end we have sigmoid for doing the classification for us, so that it can say the data, the images, including a healthy tree or not. And the dataset and code can be accessed through GitHub. This is the output of the actually the paper itself, and this is our own implementation of this actually paper, using GitHub of course, but doing some modifications. We have reached a high accuracy and a correct detection of all these parts and categories. This is our F1 score, which can be considered as a appropriate result. And here we have precision recall curve, which its minimum is around 0.9%, 0.9, which is good. It can be concluded that it has a good balance between the right healthy images being recognized and the ones that were not recognized correctly. And this is the visualized form of our data of our code implementation. This here is the output of our model, and this one was the label which was chosen for each of these images. And overall, about 90% of the images were being recognized and detected correctly. That's the end of this presentation. Thanks for having me. Hope you have a good day.